Okay, it's 5:18. This is video number 85, and today we undertake a very important theme, very important idea in Regents math, and that's the perfect square trinomial. So we'll construct a couple easy ones, and then we'll look for rules, and then in the next lecture we'll apply them to numbers, which is typically done at your age. So let's start from the beginning, and we're going to remember how to do FOIL, and this is actually an interesting application of the FOIL method that you were taught, so I'll use that exclusively, although you could use the other methods that I taught you. And now we consider a square and then a bigger square. So this square is x, that means any number. There's no restriction because 0 squared is just 0. So any number you can think of squared is some sort of positive number. And over here, we just add 1 to whatever number we thought of. And this is the whole idea of a binomial. So here are two terms, can't combine them, and this is getting at the essence of what the math is. Now I'm going to go over on the other side and FOIL this. You'll see why it makes a lot of sense. This we're familiar with in 8th grade. This is what it's all about now in 9th grade. So let's FOIL it, because after all, anything squared is just a number times itself. You learned that in 8th grade. So this is just equivalent to this. And you should think about what I just did. After all, it's really easy math when you think of it. So then I'll FOIL, and I'll go out of my way this time, but you're going to notice that we're going to start to get a little bit more sophisticated. So anyway, x times x is x squared. X times 1, 1 times x. Okay. And then 1 times 1 is 1 squared, so that's 1. I'm going to put the square there for a reason. So when I do all this, I write all this out, we start to look for some interesting patterns. And that's what math is all about anyway. Okay, so I focus you in here. It's a little cramped there. And then, of course, I come out with the answer when I add the x's together. And we're going to give this a name, this format, this pattern, if you like, a name. And we're going to call these perfect square trinomials. And I'm going to add the coefficient here and square it and square this. And what we're going to say is when we FOIL a binomial times itself, we come up with a pattern. And the pattern is called a perfect square trinomial. So what you do, and what I'm going to do now, is I'm going to imagine a much more complicated square. And I'm going to say the side, because a square has 4 equal sides. We could calculate the perimeter, right? And now we're just trying to figure out the area. And so the area is going to be, in this particular case, it's a binomial. It's going to be 2x plus 1 squared. And here I go again, left to right. And that means that I'm going to get 2x plus 1 times 2x plus 1. Now, I'm going to pause here, and I'm going to do something a little different away from the FOIL. FOIL works perfectly. You can use that all the time. But the math where we're going sort of is going to take us to this idea here. And I'm going to square the f, square the L, and then take 2 times the O and the I. And that's the outer and the inner. And when I do that, that might turn out to be a better way to calculate these guys. All right? As long as it's a binomial times itself. So I'm going to do that now, and then I'll FOIL it and check it. But this pattern that I just wrote out here, that's what we'll be looking for. Because again, we'll be looking to go from here to here. Again, I'm going to call that factoring, binomial factoring. That's where we're going. So that's what I have in mind when I'm teaching this. So I'm going to do that. The first terms I'm going to square, that's 4x squared. The last term I'm going to square is 1. And then I'm just going to double 1 times 2x, because 2x times 1 is the same thing. And I get 4x. So the answer, quickly written in standard form, is 4x squared plus 4x plus 1. And now I want you to see what I really want you to see. The first term and the last term have to be perfect squares. And why? Because when you multiply first times itself, by definition, when you multiply anything times itself, you get a perfect square. And when you multiply, here from last to last, okay, you get a perfect square, because since you're multiplying by the same binomial, they have to be the number times itself when it's the second term. So there we go, and we've just found a pattern that we can use in our math. And I'm going to let you think about what I just explained to you now. Let me clear the board just for a second, okay? And using this side, let me move over here just a bit and up. And I'm going to use my method to quickly calculate perfect squares and perfect square trinomials and look for patterns. And let's see what we can come up with. I definitely don't want to do too much in this first lecture, because I want you to think about what I'm actually doing. Drying it off here. And I'm going to just write out a couple of them. And I want you to think about what I'm doing, okay? And again, I'm looking for patterns and trying to go fast. So let's try 3x plus 4 squared, okay? And now, of course, we looked at everything before, and it's just a binomial times itself. So the answer has to be a perfect square trinomial. So if I think again, f squared plus L squared, so I'm multiplying this times itself and this times itself, right? And then I'm multiplying twice times what the middle terms are. Well, I see a 3x, and then I see a 4, then I'm done. And it's very important in math to see these kind of patterns, okay? So 3x squared is 9x squared, right? Number times itself, plus 16. And then 3 times 4 is 12 times 2, and there we go, 24x. Of course, standard form is very important. And I write everything out, and I got the answer really quick, and that turns out to be a perfect square trinomial. What are its properties? The properties are the first term, the first coefficient is a perfect square. The last number, or the last coefficient, because that's times x to the 0, is a perfect square, and the double the product of the middle. So it's 3 times 4 times 2. And I'd like to just hold off on that, because I'm going to give you problems with numbers and other perfect squares that take advantage of this. So I want you to take a good look at what I did and see if you can't do these patterns. Okay, so this represents some sort of square. We're going back here again, right? And we said one of the sides just happens to be 3 times any number plus 4, whatever that would mean to you. And I square it to find the area. I add it up to find the perimeter. We talked about that. So let's just see what happens and what's the difference when we imagine 3 times the number minus 4. So what happens here? And here we miss, again, take and go of the class. For you to be able to think about what I'm doing, it's a real pity. This is really not the proper way to teach something like this. But what I'm going to do now is I'm going to write everything out, and I'm going to square this. And I'm going to square this, but a negative times a negative is a positive. We agreed to that in 6th grade, hopefully. Okay? And now what do I do with the middle terms? Well, it turns out, in this case, if you FOIL it out, you're going to subtract, and then you're going to get 2 times 3x, whoops, times 4. Let's make sure that's still coming out over here. There you go, okay? And there we have that one easily done. And we get 9x squared plus 16 minus, of course, 24x. And you should be looking at these patterns. These patterns are very important. So if I square something, if I square with the second term positive, I add twice times the middle term. If I subtract, then it's just minus twice times the middle term. And you should be looking at this and taking keen interest in this, because if you follow what I'm saying, you can save yourself a lot of time in math and a lot of misery multiplying when you really don't have to. So there's the basic idea. That's what we did. If the second term is positive, then of course what we did over here is f squared plus L squared, because any number times itself has to be positive, right? So we don't have to worry about that. But because the second term was negative, then we did this. So there you go. There's a basic technical explanation that finishes it forever as long as it's a binomial times itself. So a binomial times a binomial gives you the FOIL, and these are the patterns that are formed. And these patterns will be very, very important for us when we go back to factoring, excuse me. So I'll leave it there, and we'll go back to this, and we'll look at an application for numbers, and then of course we can subtract areas and stuff like that. Kind of boring, but they do that on the test. And then when we're done with this, there's one more pattern I want you to look at, so I'll have to talk about that as well.